Okay, I see, Cheryl, that you came up with an answer. Do you want to tell us how you got to that?
All right.
Do you want to tell us how you first got to this? Remember?
Yes.
Okay, what did
I put like I substitute like 8. I put 8 on the first one. I multiply 8 through the first one, the first equation.
She wants to get rid of the y's.
Minus 8, yes. So I use my.
Okay, well, let's just do the numbers.
And that by 1.
And
1, yes.
And you decided, did you need a negative sign?
Yes.
Did it matter which one you picked to be the negative?
So I use the minus 8.
Okay,
negative.
So put the minus. Again, and she's very smart for getting rid of the y's, because the actual question was, how many children's tickets were sold? So the children's tickets were X. So we're looking for the value of X. So that means that it makes more sense to get rid of the Y. If you got rid of the X, it would work also, but then you'd have a little bit extra work. But sometimes it pays just really read that question carefully. And if it just asks you for one of the values, make sure that you're getting the right one. We said children's tickets stand for X. That's what we're looking for. We're looking for the value of X. So we're trying to get rid of the Y. Okay, so what did you get for your first equation?
Minus 8x plus 8y.
Is it plus 8y?
Minus 8y, minus 8y, minus, sorry about that. Equals minus 7,400.
7,400.
Yes.
You got that. I hope using your calculator by using -8 times 925.
Yes.
Good.
And then 6x.
Right. You're multiplying this by 1, so nothing's changed.
Yes. Plus 8y equals 6,000. So we're gonna have 2x.
Positive or negative?
Positive.
Wait, this is a -8x and a positive 6x.
All right.
So that's going to give us a negative. And the y's cancel out.
Yes.
And here you have how much?
1,400.
Again, negative because the larger number is negative. So it's -1400
over 2, over minus 2.
So that gave us that x equals
minus 700. Yes.
And x is the number of children's tickets. Since they didn't ask me, I could stop right here. They didn't ask me. Usually they ask how much are these children's tickets, how much are the adult tickets. But in this case, the question was how many children's tickets were sold. I'm telling you this because this comes up on the midterm, on the final, when they ask these kind of questions. Sometimes they ask you for both, and then they'll write the adult tickets are this, the children's tickets are this. But sometimes they just ask you to figure out one of them. And if you had figured out the Y, you would have gotten 225. Would have been the right answer for adult tickets, but if you wrote that as the answer for the children's tickets, you would have gotten the question wrong. So you did that very nicely. Thank you, Cheryl, for helping us out.
I was saying, sorry, good morning. This is Jonathan speaking. You know, I was doing that. I was going to subtract, multiply it, the first equation by -8.
You know,
but
Jonathan, you're going to have to talk closer to your device because I don't hear you clearly.
You hear me now?
Can you say it again?
I was saying that I was going to multiply the. Yes. Can you hear me?
I hear you now. You were going to multiply
the first equation by -8, but I stopped myself because I was like, okay, no, it cannot be a negative amount of tickets. Like I made it up to the part where it's
But
like
if you notice,
-8x.
the reason you could
What?
do that is because eventually there were negatives on both sides, so your final answer came out to be positive. But you're
Yeah.
100% right. If you work this whole thing out and your answer comes out to be -700, obviously you've done something wrong, because
Yeah.
these type of questions, you can't have a negative amount of tickets. But in the middle of the problem, you could have negatives, because in
Yeah.
that case, you would have two negatives. Does that make sense to you?
Yes, you need to go and tell him you're going on to Mr.
Yeah, it does. Thanks.
I'm muting. I muted everybody. So, Jonathan, if you want to say anything, you're going to have to unmute yourself again because there was too much background noise.
No, it's fine.
Are
I
you
get
okay
it.
now?
Yeah, I get it. Thank you.
Okay, great. As I said, let's do one more problem like this, just to keep us, see if we really got the idea, and then we'll go on to some new material.
Professor, oh,
Yeah.
forget it. You erased it. I was going to ask, how would the problem be if we were to search for how many adult tickets were sold?
If the question would have been how much, okay. Let's say the question before. So if they asked me, look I already figured out that X is 700. So that was the children's tickets. I could then go to one of the original equations. I'll take the first one, which says X plus Y equals 925. And replace, now I know what the X is. The X is 700. So I could do 700 plus Y equals 925. And then subtract 700 from both sides, which would give me that the Y, I'm trying to not go too low, is 925 minus 700, which is 225. So once you have one, you could always figure out the other one, but we didn't have to because the question was just how many children's tickets.
Great, thank you so much.
Okay, so I'm going to write another problem on the board, similar type. Actually, let me see. Let me do one of the questions that's on the practice sheet, because this is a similar type question. Okay, I'm going to erase this now. And again, I'll give you a few minutes to try and set up a system of equations. Okay, so here's what the question says. If you have practice sheet 3, it happens to be question number 9. Chad sold 30 decorated sweatshirts. Okay, they're decorated, but I'm just calling them sweatshirts. At a craft show. Now, it's all nice to hear the story, but I'm just going to put the important information. Here's the important information. The white sweatshirts cost $10 each. And black sweatshirts, they're fancier, so they cost $15 each. Right, so we're not talking about tickets. In this case, we're talking about a different type of item. We're talking about clothing, but the idea is the same. We're talking about things, how much individual things cost. Now, he made a total of $390 at the craft show. And we want to know how many black shirts did he sell? And also, how many white did he sell? In other words, how many did he sell of each type of shirt? Okay, I'm going to give you time to set up an equation and try and solve that. Are giving answers. And Katira, I see you wrote two equations. You want to give me those two equations and tell me how you got to them, what you called each thing? Are you willing to talk to us, Katira? Oh, your mic is not working. Anybody else? I see, let me see who else. I think Jonathan got the right answer. Jonathan, you wanna try and,
Okay. I can do it.
but you have to say it loud because I
Okay.
don't hear you.
Okay. So I did x plus y equals 30.
What's X and what's Y?
X is the white shirts, white sweatshirts, and black is the white. Y is the black sweatshirts.
Okay, what about them?
The total number of white and black sweatshirt equals to 30.
If you notice, I'm trying to be very specific as to know, because once you know exactly what your variable stands for, it's much easier to write the equation. The X is the number of white shirts. That's what he's calling X. And the Y is the number of black sweatshirts.
Mhm.
So it's not enough to say white shirts because there are a lot of things you could have, a lot of features on white shirts. It could be how long the arms are. I don't know. So we very specifically are saying X is the number of white shirts and Y is the number of black shirts. Okay. Now you can write, what was your first equation?
X plus y equals to 30.
Right. And why did you do that?
Because the total number of white sweatshirts and black sweatshirts equated to 30 sweatshirts in total that Chad sold.
Right. Since they told us he sold, when it says he sold 30 sweatshirts, it's just telling us how many altogether.
Yeah.
So he sold white and black ones. So altogether, in other words, plus, you get 30. Perfect. What was your second equation?
My second equation was 10x plus 15y equals to 390.
And you got that because what did the X and what did you include here now?
The price of the white sweatshirts and the black sweatshirts, which was $10 and $15.
Right.
And it equal to
When you're talking about
$390.
390, which was the total amount of money that he made, you have to include not only how many there were, but how much each one cost. Okay.
So the next thing.
Wait, let me just start. Does anybody have any question? This is a perfect setup. It's a perfect setup. He's got both equations correct. And we have very clearly stated what my X and my Y, even if you don't write it out specifically, you have to keep in mind, because if not, you're going to mix it up. You're going to say, oh, X, I really meant X to be white, but I made a mistake and I used it for black. Write it out or put it very clearly in your mind so you know what your variables stand for. Okay, how did you go about and solve that?
Okay, and then I decided that I wanted to get 10 by itself, well, y by itself. So I multiplied x plus y equals 30 by negative 10.
Okay. He decided he wants to get rid of the X.
Yes.
And you used, and why did you use a negative?
Because a negative and a negative can, if it's a negative 10 plus 10, it will cancel out.
Right. In other words, I'm multiplying this one by 1 and this one by 10, but since they're both positive, I had to use a negative.
Yeah.
Okay, so let's see what you got.
So I got negative 10x plus 10y.
Plus 10y?
Is it 10y? Oh, minus 10y.
Minus.
Be very careful with those signs.
Yeah. Equals to negative 300.
Correct.
And then plus 10x plus 15 equals 390. So the x crosses out.
Right.
Then I got 5y equals to 90.
Okay, so a negative 10 and a plus 15 gives us 5, negative 300 and positive 390 gives us 90.
Divided by 5. And then y equals to 18. Y meaning the number of black sweatshirts was going to be 18.
Okay.
18 black sweatshirts were sold.
So how did you figure out how many white shirts were sold?
I just did 30 minus 18, and I got 12.
Okay. Since the x plus y equals 30, you could have right away done x plus 18 equals 30. He actually even did it in his head, I think,
Mm-hmm.
and subtracted 18 from both sides, and that gave us x equals 12. So 12 white sweatshirts were sold and 18 black. That was beautiful.
Thank you.
I'm going to put you as give some extra credit here. Okay. And Cheryl gets extra credit also. Okay. I think we have covered this as again, the best practice on this, of course, is on practice sheet 3, because those are straight from the department. I will be giving you some examples similar to this on Delta Math, but it's going to be optional for extra credit. And we have now basically finished the first 3 chapters in Math 136. We've done solving equations and inequalities. We did, and you have to know how to solve equations even if they have decimals in them. And we haven't done anything with fractions. Before we get to the midterm, I'm going to work with fractions as well. But right now we've done equations, linear equations, solving equations with whole numbers and with decimals. We also could get an answer with a fraction in it, but that would be just from the last step. We also solve inequalities, and we put the inequalities on the number line and in interval notation, and we solve absolute value equations. That was chapter 1. Chapter 2, we talked about graphing. We talked about how to graph lines. We talked about the slope and what the slope stands for, and the parallel and the perpendicular lines. And we talked about writing the equation of the line. And chapter 3 was what we called systems of equations. And we talked about how to solve the system of equation graphically and how to do it algebraically, either by elimination or substitution. And then this last thing we talked about, solving word problems. So this is the second type of word problems we're doing. We did perimeter problems in rectangles, and now we did system of equations problems of this nature. And now we're going to be starting what's called chapter 4. Chapter 4 is going back to working with algebra and how to work with algebraic terms, how to add subtract, multiply, and divide different polynomials or monomials. And then we're going to talk about factoring. And that's basically what we're going to be doing in chapter 4. So let's start with some basics that I think everybody will remember once we talk about it. And then we'll go on to the hard stuff, which is the factoring of polynomials. So when we talk about let's use some terms. We first could talk about something called a monomial. And you see this mo or mono, that prefix usually stands for 1. And nomial means number. It's one number. Now remember, when we're talking about algebra, our numbers are either regular numbers that we recognize, or they could be even letters, what we call variables, because if we don't know, we have an unknown, or we want to talk about something in general, instead of using an actual number, we can use a letter instead of the number. And therefore, if I write something like 8x squared y to the third, this is really a single number in algebra. So including the letters included are part of the number. Now, when everything is connected by the operation of multiplication, and this is, because this really means 8 times x squared, well, x squared means x times x, times y to the third, which means y multiplied 3 times. So everything here is being connected. The only operation is multiplication. Then that is called a single term or a monomial. It's one term. A term is everything connected just by the operation of multiplication. As a matter of fact, what's very interesting in algebra, if I write something like 8x, that's telling you what you want to do is multiply 8 times x. Anytime you have two letters next to each other or a number next to a letter, it means that the operation between them, you don't even have to put the dot there or the time sign. It is understood to be multiplication. Now that isn't how it works in regular arithmetic, because if I wrote two letters next to each other like this, an 8 right next to a 5, you would read that as 85 and you would be totally correct. That doesn't mean 8 times 5, but as soon as instead of using a actual number, you're using a letter, a variable. When you have two letters next to each other, or you have a number and a letter next to each other, then it means that what you're doing to these two things is you're multiplying them. So there's where we're going to have to be very careful when it comes to expressing ourselves, that we keep in mind that things in algebra, letters next to each other mean multiplying. But when the numbers are next to each other, means that they're just the number. Now, this we said was a monomial. So what is a polynomial? A polynomial consists of more than one term. Poly meaning many or more than one. So if I write something like this, 8x plus 9y, this would be a type of polynomial. there are, in this case, two terms. As soon as the operation between them is either plus or minus, then you have separate terms. This means 8x means I'm multiplying 8 times x. 9y means I'm multiplying the 9 times whatever the y is. And the plus in between them obviously means that I am adding them. And these, by the way, are what we call unlike terms. Like terms means that the letter parts, the variable parts, are identical. When the two letter parts are not identical, they are unlike terms. Now, actually, in this particular expression here, 8x plus 9y, it's not an equation, it's just an algebraic expression because there's no equal sign. We're not solving anything. We just have two terms added together. This is actually called a binomial because there are exactly two terms. So polynomials can be any number of terms. A binomial, if there are only two terms, we call it a binomial. If there are three terms, we call it a trinomial. If there are more than three terms, we just say, oh, it's 4 terms, it's 5 terms, whatever. We don't have special names for them. So the first thing that we're going to talk about is combining polynomials. How do we take algebraic expressions and combine them to make them as simple as possible? And the rule is you can combine like terms, but you cannot combine unlike terms. So what makes, remember what we said, what makes like terms is that they have exactly the same letter part. So if I have something like this, 8x squared y to the third minus 17x squared y to the third, I have this binomial. Actually, if I look at the literal parts, the letters, this is an x squared, an x to the 2, a y to the third. And this is also an x squared and a y to the third. The letter parts are identical. This means they are like terms. And therefore, we can combine them by just looking at the coefficients, the numbers in front. This is an 8 minus 17. I totally ignore the letters. 8 minus 17 gives me -9. So my final answer becomes -9x squared y to the third. So sometimes we can combine them. If this question would have been...
It's not 2y to the third?
What?
It's not 2y to the third?
No, you don't. All you do is you look at the numbers in front, the coefficient, which is the 8 and the -17, and you combine those, and that gives you your number that goes in front of your answer. You don't do anything with the letter part. Is that clear?
Yeah, that makes sense because it has a coefficient that can be combined.
Right.
Okay.
Now, what if the question would have been 8x squared y to the third minus 17 x to the third y squared? Now you look at them and they almost look alike. They both have x's and y's, and one has an exponent of 2 and one has an exponent of 3. But if you really compare them, here it's the x that has the exponent of 3 and the y that has an exponent of 2. And here the x has an exponent of 2 and the y exponent is 3. These are not like terms. They can only be like terms if the letter parts are identical. Same letters, same exponents. If they aren't, you cannot combine them. This is as simple as you could get. You cannot combine because these are not like terms. So in terms of adding and subtracting of polynomials, you look for like terms. In other words, you look for the letter parts that are the same. And then just combine the numbers in front, the coefficients. Don't touch the letter parts at all. Okay, so let's take an example.
I'm sorry. You said that's a simple answer because there's no like terms, correct?
Right.
Okay, thanks.
So let's take an example that looks like this. Let me take one off the practice sheet. We're jumping right into the hard ones. Suppose I told you, it says perform the indicated operation. Here's the example. 3x third minus 8x squared plus 4x and my plus 4 minus negative 4x to the third minus 7x squared plus 4x minus 7. Okay, let's say I have these two polynomials. And I can't even give them special names. They're not binomials, they're not trinomials. Each of these polynomials has 4 terms. We want to combine the like terms if possible. Before we get into that, let me just give you again some information. Notice in this case, we don't have 2 variables, we only have 1 variable. Everything is in terms of x. Not only that, if you look at the exponents, this is an exponent of 3, this is an exponent of 2, this is an exponent, well, there's no exponent, so it's understood to be 1, and then there's no x. That type of polynomial is what we call arranged in descending order. It's not absolutely necessary to arrange things in descending order, but it's very organized to do it that way, where you start and you put your polynomials, if there's only, when there are 2 variables, you don't really do this, but when there's only 1 variable, try to put your terms in such a way that the highest exponent comes first, then the next highest exponent, etc., etc. Now, if I look at each one of these separately, there are no like terms, because even though all 3 have x's, their exponents are different. So this is one polynomial, that's the other polynomial. And the sign in between them is a negative. Now we've done this before. When we have a negative in front of a parentheses and there's no number there, we understand that the number there is understood to be a 1. It's as if there's a negative 1 in front of that second parentheses. In front of this first parentheses, there's no number, so that's just like a positive 1. To remove the parentheses, obviously multiplying by 1, in other words, if there's no number in front of the parentheses and no sign, you don't need that parentheses, you just leave that 3x to the third minus 8x squared plus 4x plus 4 for your first polynomial. And the second polynomial having a negative in front of it means we're really multiplying everything by -1. So -1 times -4x cubed becomes a positive 4x cubed. Then -1 times -7x squared is a positive 7x squared. -1 times 4x gives me -4x. And -1 times -7 becomes positive 7. So if we have parentheses, we do what we've done before. We remove the parentheses. And then we try and find the like terms. So the first term in this, there are 1, 2, 3, 4, 5, 6. I have a total of 8 terms. The first term is the 3x to the third. The one that's like it is the
4x to the third.
So I have to combine the 3x to the third and the 4x to the third. And remember, I only combine the numbers in front, the coefficients. So the 3 and the 4 become 7. So that becomes 7x to the third. Then we look at the next term. And if you want, you could either put a line through it or a check mark to say, okay, I've taken care of that one. Because when there's so many, sometimes you don't want to forget that any of them. So that might be a good idea. We now have a negative 8x squared, and there's another x squared term of 7x squared. So I have to add the negative 8 and the positive 7, which gives me a negative 1x squared. Usually when the coefficient is 1, we don't even put it in. We just write negative x squared. It's not wrong to write negative 1x squared, but usually the accepted way is to write it without the 1. So now we've taken care of the x squared. So now we go to the x's. Here there's a positive 4x and there's a negative 4x. Now 4 and negative 4, when you combine them, is 0. So I don't have any x's left. I don't even have to put it in. I don't have to write 0 x's. There are no x's left. Forget it. And finally, I have just my plain number 4 with my plain number 7, which is plus 11. And this would be my answer to this, combining these two polynomials. Notice I did it term by term. Only the like terms can be combined.
What's up, bitch?
What? Sorry?
What's up, bitch?
I can't hear what you're saying.
I think they're trolling.
I think they just hacked our damn class again.
Yeah.
Oh. Let me see if there's,
That person is not supposed to be there. That person with the little face.
Face, yeah.
Yes, that's not supposed to be there.
can you see it now?
Yeah, they're there.
Yeah.
Okay, is there anybody who came on who was not here before? I'm going to,
That thing with the I think it's a square or something like that.
Yeah, just the one with the the face, like the little yellow face, the emoji.
That little yellow emoji face.
okay, let me get rid of him. I'm removing him, okay? Okay, is that better?
Yeah.
Okay.
Thank you.
What are you looking at? What are you looking at? What are you looking at? What are you looking at, Poppy?
Okay, I'm going to give you one to try.
Hey, bitch.
Okay, so here's one for you to try. had told you this, subtract 3x squared minus 5x minus 10 from 2x squared plus 10x minus 17. This you're going to have to be careful about because I didn't set it up for you. You have to set it up yourself. Remember when it says subtract, I'll put them in parentheses so you'll be able to see. The first from the second, which one would you write first?
We would write the 3x.
Because of the, yeah.
Which one do we write first?
The 3x to the second.
No. What if I said subtract 10 from 20? How would you write that? To subtract 10 from 20.
20 minus 10.
20 minus 10.
You have to write the 20 first and then minus 10. The expression after the from is the one that goes first. This is again one of those situations where the way we say things in English doesn't really always line up with the way we say them in algebra.
Shut the fuck up.
So
Ass.
That's Jones. You need to.
So you have to put the 2x squared plus the 10x minus 17 first, because that's after the word from, and the 3x squared minus 5x minus 10 second. Okay, I'm going to give you a couple of seconds to try this.
To rewrite it?
To write it and get the final answer.
Okay.
Anybody want to tell me how to go about this, how to set it up and what to do? Anybody willing to?
I'll give it a try, Professor. It's me, Jennifer. I'll
Okay.
try.
Okay, Jennifer is going to help us with this. Okay, what should I put first?
I put 2x squared.
Did you put it in the parentheses or
Yeah,
not?
parentheses.
Right, okay, 2x squared plus 10x minus 17.
Yeah, close parentheses. Minus 3x squared minus 5x minus 10.
So that would be perfect. Number one, make sure when you read something that you do it in the order, it's a proper order that it's supposed to be done, okay?
So I'm gonna, I like I said, I don't know if I'm right, but I put 1 in front of the parentheses right here.
This one?
Yeah, a positive 1, and right here where the minus is, there'll be another 1 will be, then you will have -1. So I got 2x squared plus 10x minus 17. It says the whole equation stays the same. Then it's minus -3 squared.
Wait, how many minuses?
This is where I said I was confused.
Okay, this is a -1.
But this is a positive, so it's a -3.
Right.
Times -1 times -5 equals a +5.
Right.
And -10, I mean -1 times -10 is +10.
Perfect.
And then you just combine like terms.
Okay.
2x squared minus 3x squared gives you x squared.
Positive or negative?
I hate signs. Positive.
Wait, this is a +2, this is a -3. What's your final answer gonna be?
Negative.
Negative, right, because you always take the sign of the larger one. And you could have written -1x², but better to write it, don't put in a 1 when its coefficient is 1, okay?
Then you have the 10, +10 plus +5 equals +15.
So we have 15x.
And then you have the -17 and the +10 that gives you -7.
Perfect. Can you do anything more with this?
No.
No, because there are no like terms. So your final answer is -x² plus 15x minus 7, which, Stacia, thank you. That was exactly the right answer. Okay, so that takes care of adding and subtracting of polynomials, and obviously monomials as well, because if you add two monomials, you're going to have either a polynomial or a monomial if the terms are like or not. So let's go on to multiplication. Let's just start talking about multiplying polynomials. Well, we'll start with multiplying monomials, and then we'll go on to talk about multiplying polynomials. So when we are multiplying, you do not have to have like terms. Remember, for adding and subtracting, you can only combine them if the terms are alike. But if you're multiplying, let's say I have -3x² y to the 4th, and I'm multiplying. Now I could either put a dot in between them, or I could just put them right next to the two parentheses right next to each other means that we're multiplying. Let's say we have 4x4 y. Now, obviously, these are not like terms because they have different exponents. But the operation is not addition, there's no plus or minus in between them, it's multiplication. So the way we multiply is we multiply piece by piece. We multiply the coefficients together, then we multiply each variable together. And the big thing to remember about multiplication when it comes to the variables is that if you have exponents, when you multiply, what do we do to those exponents? Anybody know?
You also
You add them.
You add them.
Add the
Add them.
exponents. Right. So when I want to multiply this, I'm going to do -3 times 4. That'll give me -12 because a negative times a positive is negative. And then I'm going to multiply the x² times the x4. So I'm going to add the exponents. They have to have the same base. They both have to be x's. The base is what has the exponent. The exponent is sometimes called the power as well. This is an exponent of 2. This is an exponent of 4. When we add 2 and 4, we get 6. So this becomes x to the 6th. Then we have a y4 and a y. Notice they're the same letter also. They're the same base. Here the exponent is 4. Remember, when a letter has no exponent, it's understood that the exponent is 1. So this becomes 4 plus 1, so it's y to the 5th.
Okay.
So when we're multiplying, we don't have to have like terms, and we multiply the coefficients together, then we multiply the letters together. The like letters we multiply by adding their exponents.
Okay. So when it's multiplication, you just add exponents, correct?
Correct.
Okay, thank you.
Now, I'm going to do one more problem, and I'm going to give you one to try. Sometimes this was one monomial times another monomial. What if I have a monomial? Let's say I have 3x fourth y third times a binomial, 2x minus 7xy third. How do we multiply a monomial times a binomial? Or in general, how do we multiply a single term times a polynomial? And everybody's going to remember that we do this by using what's called the distributive property. We'll first take the 3x fourth y cubed and multiply it by the first term, which is the 2x. Then we'll go back and we'll multiply the 3x fourth y cubed times the negative 7xy cubed. And we'll be sure to look at the end to see if there are possibly any like terms. If there are like terms, we could either, these are not like terms, but if they were, we could have combined them first. But it doesn't matter. You could either multiply first and then combine, or you can combine first and multiply second. As long as you do both of those things, you multiply each term in your polynomial by the monomial and make sure to check if you have like terms. So doing the multiplication, multiplying the 3x fourth y cubed times the 2x, the 3 times the 2 gives me 6. X fourth times x. Remember, no exponent means it's exponent of 1. So 1 and 4 is x5. Y cubed, there's no y to multiply it with, so I just bring the y to the third across. So I multiply coefficients and like letters. Once I've done my first term, I go to my second term. I have a 3 times a negative 7. Remember, the negative is part of the coefficient. 3 times negative 7 gives me minus 21. X fourth times x, again, the exponent is 1 and 4, gives me 5, x to the 5th. And this is y third times y third. I can add those, that gives me y to the 6th. Now, these are not like terms, so here is my answer. I can't combine these, so my answer is 6x fifth y cubed minus 21x fifth y sixth. Okay, let me give you one to try, and then this is where we'll leave off today, and we'll talk about tomorrow what happens if we have, let's say, 2 binomials. What happens when we have a monomial times, we've seen a monomial times a polynomial. What happens if we have 2 polynomials to multiply? So let's say I have this example. I have a 5a squared b squared times 8a squared minus 2ab plus b squared. So I'm multiplying a monomial because the 5a squared b squared is one term, and we're multiplying it by a trinomial. Okay, I'm going to give you a couple minutes to try this, and then we'll go over the answer. Remembering that we're going to take this 5a squared b squared and multiply by each one of these 3 terms. We know this is 3 terms because they're either, terms are separated either with minuses or plus. As long as everything's connected together, it's a single term. Once you have a plus or minus in between two letters or two numbers, that makes it another term. So multiplying the 5a squared b squared times the 8a squared, 5 times 8 gives me 40. A squared times a squared, so we add the 2 and the 2 gives me a to the 4th. There's nothing to multiply the b with, so I just bring the b squared over. That's my first term. Now I go to the second term. The 5 times the -2 is -10. The a squared times the a. Remember, no exponent means that it's an exponent of 1. So 2 plus 1 is 3. So it's a to the 3rd. And b to the 2nd, and b gives me also b to the 3rd. And finally, 5 times, well, there's no number in front of the b squared, so it's understood to be a 1. So that's going to be a plus. I'm going to put it down here. 5. A squared, nothing to multiply it by, so I just bring it over. And b squared times b squared, again, I add the exponents. 2 plus 2 is 4. So my final answer comes out to be 40a4 b squared minus 10a3 b3 plus 5a squared b4. Now, if you look at these two, they almost look like terms, but they're not, because here the a has an exponent of 4 and the b has an exponent of 2. And here the a has the exponent 2 and the b has the exponent 4. They have to be the same letters with the exact same exponents. Okay, so this would be our final answer. You can't even simplify this anymore. So this is multiplying a monomial times a polynomial. As I said, next time, tomorrow, we're going to start talking about multiplying two polynomials together. Okay, again, let me reiterate. First of all, you have until tomorrow evening to do the quiz number 2 in Delta Math. If you had any problems with it and you want to restart it, just send me an email. I'll reset it for you. I have no problem with doing that. Again, I'm going to be sending out a new passcode. I know this is ridiculous, but
Can we do a thing where you have to accept the people who join?
yeah, I could do that. I could, but you know what? Then it
Yeah,
means
do
I'm
that.
gonna be.
Professor, you can give me the host and I can do it. That's what I was gonna say.
Yeah,
You wouldn't
because
have to do it.
Because there's somebody in here who needs to seriously grow up and understand other people trying to learn, and this is not
Exactly.
and it's not cool.
Yeah,
So
because
whoever it is, if you don't want to learn, you need to do about your business and get out, because there's other
Yeah.
people who are trying to pay attention, and it's really messed up for other people who are trying to do their work.
and it's like I was talking to Jennifer earlier. It's like I feel as though, personally speaking, I'm speaking for myself. I feel as though somebody in here is giving out the passcode.
They
Because
Obviously, you're right.
somebody doing it, because it makes no sense.
Okay, first of all, I
First
don't
all
know
I
if you-
listen to you and I go on like him not in the class. Somebody I listen and another person there, yeah.
But does other classes have the same password too?
No, I don't have.
It's a password. That's a passcode that I made up. I just made it up. So it was somebody in this class that
Somebody in
put
here is
in
giving
out
it
that
out.
passcode. Now, first of all, I'm going to insist that, because I don't know if you noticed, I've been going through and I've been removing people. Anybody whose name I did not recognize, I removed from the class.
This class usually has 21 people, and today
I could. I'm gonna leave it like this time, but Melissa, if it works again, then I will make you the host and I'll ask you to just allow. The problem with, I have this in my other school, I have to admit people. And what happens is then somebody gets knocked off the internet, then and you're busy with it the whole time, admitting and admitting. So I prefer doing it just with a passcode. But if we have this again, I'm going to have to then go ahead and and put what they call a waiting room on here. Again, I hesitate doing it because I find it's disruptive to the class.
I can't fuck with my nails.
Exactly. You
Yes,
see,
ma'am.
that's
No,
not
somebody is on, see, I'm gonna
Finish.
remove this person right now.
so childish. Like you guys need to stop.
Girl, shut up. You childish and your pussy smell like a
You're
bitch.
childish.
Shut the fuck up.
Nisha,
Pussy ass
I
bitch.
truly
Okay,
feel
so
like
Listen, just please, not
Tanisha.
argue with them.
Don't
Please,
argue with them.
just make
Like,
them
I
Yeah.
think
talk.
Tanisha.
yeah,
This
just say
don't
no.
make no
I
sense.
fact
I
that think
swear.
Tanisha.
Okay,
How
let's,
much you wanna bet?
please, anybody, if you have any evidence,
I
or
think
you
it's
have, if
Denisha,
you
like
think you
for a
know
fact.
who is behind this, please let me know. I will deal with that person personally.
Yeah.
Correct.
Professor, I have one
Next
question.
call, not
When you're
childish.
sending out the password in our emails, do
Yes,
you do it like to every student in the class, or you send it
No.
out personally?
Shut the fuck up.
I
Nobody
have to do it to
If
everybody
it's
who's in the
from
class
somebody
because I don't know
from,
who's
like, I think
behind
it's
this.
Denisha.
And I have to give
That's the
everybody
thing,
the
Denisha.
opportunity.
Professor. I think
I
you
think
could
it's
just like send it to us
Denisha.
privately
That's
I
because
think he
fact.
didn't
we don't know
even
for sure
Yeah,
if
I'm a guy,
person
but I'm not the
that's
one to
in
mess
the
with.
class
I
is
truly think
coming
that
to
is
class,
Denisha who's doing that.
but they're already
I think
registered
it's
in
her.
the class. So like they'll be
Think
seeing
about
the
it. It's like,
emails and
okay,
everything,
she
but you don't know
asked,
for
she
sure
one
who
time
is
she
it.
sent a
Sorry, there's too
thing
much
in
in
the
the,
chat about
Jesus
people
Lord.
doing your homework.
okay. Stacia, unmute yourself again. There was too much back noise.
Yeah, I'm saying like for example, students, right, that was in the class but decide to drop the class.
There's
You remove
no,
them from
I
the
don't,
email?
as far as I know, I have not been informed. I would remove them from my Blackboard account. Then I'm sending it, I send out my emails through Blackboard. So if somebody has been dropped the class, they're no longer on my Blackboard.
That's all. Can you move Mel Cherry? Remove Mel Cherry.
Oh,
from the
that
class.
is, how are you gonna remove me? I'm not typing anything.
Melmo
Oh, who the
Cherry.
fuck
That's
Oh
Melissa.
God,
That's
what?
Melissa.
Wait a second. If I remove
Oh,
Mel
they,
Cherry, who is
Mel
Belinda,
is the tutor, right?
he's our tutor.
they
If
changed your
But
name
it's
to
in the
my name.
chat.
remove me.
Like, I'm looking at
Professor,
the
look in
chat
the
and